If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome to your new lecture of these advanced level quadratic equations. So where you are solving IT questions. So you have solved up to 4C. So today I will be taking from 4D, question number 5, 6, 7, 8, A, B and 9. Up to 9 we will be solving today. Okay then, let's try to solve these questions. Okay students, in question number 4D, what is asked, if alpha and beta are the roots of this, and alpha plus delta, beta plus delta, these two are the roots of this equation these two different equation, one with smaller letter, one with capital letter ABC, for the sum constant delta, then prove that this. Now you see, first before going to solution, you see the questions first. What they are doing a relation between this B and this capital this smaller ABC and capital ABC. That means the coefficient of these are related with coefficient of these. Now what is the best way to come with the coefficients is, if I know the roots, so I have to take between some relations between this ABC and this ABC. So what is the way? If I take sum of the roots, product of the roots, then I will get this A, B by A, C by A, all these things. And that means I have to somehow relate these two. Then what is the best way to relate alpha beta and alpha plus delta, beta plus delta? How I can write them together? So if I write them in this way, alpha minus beta is equal to alpha plus delta minus beta plus delta. So now you said both are equal, and obviously you involve this alpha beta also, you will form this. So the roots of this equation is also involved, roots of this equation is also involved. So that concept has been used here. So this one, alpha plus beta, is written as alpha plus delta minus beta plus delta. So this is the best way you can relate these two, and we can have both the roots in the same picture, in the same equation, left and right hand side, so that this relation can be. Now you take whole square. Now the rest things becomes very easy. A minus b whole square is a plus b whole square minus 4ab. Same thing will be here also. A minus b whole square will be a plus b. This entire thing is a, this entire thing is a. So alpha, I am not writing it, alpha plus delta plus beta plus delta whole square minus 4 into alpha plus delta into beta plus delta. Now what is alpha plus beta here? Minus b by a. So b by a square by. Now alpha beta is this. Similarly here, this plus this will be equal to this from this equation. Similarly product of this will be c by a. Now if you do this, this is coming, that is proved. Even if it is proved, but you have to do all these questions of previous year's IIT entrances. In that, at that time it was subjective type, but these concepts are very helpful for objective questions. ABC are real numbers. You careful about these words, real numbers with a is not equal to 0. Let alpha be the roots of the equations. These express the roots of these in terms of alpha beta. You need to express these roots in terms of alpha beta. Here ABCs are there, lots of ABCs, so we can correlate ABCs. If I take alpha plus beta a minus b by a, alpha beta equal to c by a. So let me write the roots. Let the roots of this version is gamma and delta. Then if I write gamma delta, sum of this root product, I will get ABC, and I will replace that ABC from here in terms of alpha beta, because I need to express it only in terms of alpha beta. So if you do gamma plus delta, then it is what is minus ABC divided by a cube, which is minus BC by a square. A will get cancelled. Now this one can be written as minus B by a and then C by a. So minus B by a is alpha plus beta, then C by a is alpha beta. So that means I can write it alpha square beta plus alpha beta square. And if I take product, that is C cube by a cube, that is C by a again, that is alpha cube, this whole cube, alpha cube, beta cube. Now you look around this. You can easily do this one. You can think in this way. I have this equation. One is this equation, and one is gamma into delta is equal to the product of these two. If you alpha cube, beta cube. So if you take this product, that also give you same alpha cube, beta cube. Now by symmetry, you can say, if I take this is alpha, this is gamma, then both the equations are satisfied. If I take this is gamma and this is delta, then both the equations are satisfied. So that's why I can say one root is alpha square beta and one other root is alpha beta square. So here you say the exact solution is not required. Once you have two equations, you can have, if you have the symmetry and you think whatever the equations are given to you, that equation should be satisfied. If that is satisfied, that is fine enough. No need to do it exactly, you need to calculate. There is no required. You have to satisfy, because these are the only given condition. Whatever the given condition in the question, that has to be satisfied. That's all. So if I consider gamma is this and delta is this, then everything is satisfied, because this is all that is given in the question. So directly you can write the answers. Now in 6, if you see in question number 6, the set of all real numbers of x for which this So this is a equation which is not exactly a quadratic equation, because quadratic equation was a standard format. Quadratic equation is this one. It is very standard, and inequality also this will be greater than less than, but here one mod is used, so it is not exactly quadratic equation, but it can be converted into two different quadratic equation. Because for mod, there is a mod is a function which has a peculiar characteristics. Suppose if I take mod of x, let me explain it here. Mod function, suppose if I say mod x means whatever value it is there. Suppose any function is written as mod x, so you can divide it into two parts. That function you can segregate into two parts. If I segregate, then I say it is piecewise defined function, that is, it is defined in small pieces. So if x is greater than 0, what is the purpose of mod? To make it positive. It will give always positive. So if x itself is positive, then there is no need of mod sign. If x is 3, then output will be always 3. There, what is the need of giving mod sign? No need. Now if x is less than 0, suppose x equal to -2, then what is the outcome of mod? Outcome is plus. So you have -2, that means you need to give one more minus. If x is negative, you give one more minus, it will be automatically plus. So the work that mod is doing, the same work can be done by this function also. So that is known as piecewise defined function. So here it is given x plus 2 is 0, mod x plus 2, some function. So that function can be written as, if x plus 2, the inside thing is, if it is positive, then there is no need of giving mod. X plus 2 is greater than 0, which implies x is greater than -2. If x is greater than -2, then it will be every time positive. Then there is no need of giving a mod sign here. So one more thing, then if it is negative, then what we have to do? We have to put a one more minus sign. No need of mod now. So it is x plus 2, and we will put a minus sign because it is negative. So x is less than -2. So there are two portions. One is this one. For x is greater than -2, it is x plus 2. For x is less than -2, it will be minus x minus 2. You have to minus x plus 2, whatever you think. So now, so the same concept is here used. So here you can see now. So one case is this one. So this one has been broken into two pieces. One piece is here, one piece is here. So if it is greater than 0, then in place of mod, I can directly write this one, x plus 2. And if it is less than 0, in place of mod, I am putting minus. One minus is already there, and again a minus x plus 2. So minus it becomes plus. Minus of x plus 2, so it will become plus. So I have two equations. One for, this is case 1, I am considering case 2. One case is for x is greater than -2. If x is greater than -2, then my equation becomes this. So if I solve this equation, it becomes like this, it becomes like this. Again, you can solve it. How you will solve it? We have seen it yesterday. Let me do it one more time. X square is greater than 2, that means x minus root 2. If I take 2 this side, or x plus root 2 is greater than 0. So we will insert a pole at plus root 2 at minus root 2. Then we will start from here, plus minus plus. Because it is positive, we need this zone. So my answer is this zone. Minus, what zone you need? You need positive zone. So this zone and this zone. Greater than 0 you need. So positive is here and here. So answer is be minus infinity to -2, and root 2 to minus infinity to minus root 2, and then root 2 to infinity. So here minus infinity to minus root 2 and root 2 to infinity. But what you have considered? While entering this path, you have considered this one. Your x should be greater than -2. So you cannot go beyond -2. So there is a boundary, because before you are entering here, you put a boundary. You have a Lakshman Rekha. You cannot cross this one. What is the boundary that was given? X is greater than -2. So here there is a -2 will be somewhere here, -2, because it is root 2 1.14414. So -2 will be somewhere. So it should be greater than this. So you cannot go beyond this. So -2 to minus root 2 will be one zone. -2 to minus root 2. Union means then summation of the next zone is root 2 to infinity, root 2 to infinity. So this is for case 1. Similarly, if you do for case 2, for it is less than 0, what is the now boundary? New boundary is this one. You should not cross this boundary. X should be less than this. Now let me solve it. So instead of that mod, it will be minus of x2. So it will be plus. So if you do this one, it will be something like this. X square plus 2x plus 2. Now you cannot factorize it. Okay. If you cannot factorize it, then you think, can you make it a perfect square, so that you can see whether it is positive or negative, what time it is becoming positive, what time it is becoming negative. So if it is not possible to make it a perfect square, then for algebraic expression, so you take it, you convert it into a perfect square. So how will convert it? A square plus 2ab plus 1, then plus 1, then I will convert it in, let me write it here. I will convert it x square plus 2 into x into 1 plus 1 square. plus 2, because this 1 square is extra, so I will minus it. So this becomes your x plus 1 whole square and 2 minus 1 1. Now if you see this graph, this one you see carefully, because I have already told you so many times, the perfect square never becomes negative, so it will be always positive and its value will be always greater than 0. If its value is always greater than 0 and you are adding 1, that means you will get a value because it is more than 0. So if you are getting 1, that means you are crossing 1. That means this value will be always more than 1, because the minimum value is 0 here. So 0 plus 1 1, so minimum value of the total expression is 1. So you cannot reach below 1, so your answer will be always greater than 1. So because it is greater than 1, it is always positive. Whatever value of x you take, it will be always positive. I need only positive. So my answer is minus infinity to infinity. But my boundary was at minus root 2. By my boundary was at minus root 2, my x should be less than this. So I cannot go beyond that. So my answer will be minus infinity to minus 2. So I have these two answers. So these two I have to club and I have to, because my x is, if x is here, then also it is satisfied. It is satisfied through case 1. If it is here, then also it is satisfied through case 2. So total solution will be from minus infinity to you come minus 2. Okay, from minus infinity to, you can see the graph. From minus infinity to I came minus 2. I came minus 2. Then from minus 2 to it is minus root 2. Minus 2 to minus root 2 here. That also is an answer. So I can write directly from minus infinity to minus root 2, including this and this. Union, positive side only this one, root 2 to infinity root 2. So this is, if x square plus this equation is given to you, or AB is a real number, then find the values of A for which the equation has unequal real roots for all values of B. This is a very important statement. For all values of B, that you have to think. So for unequal real roots, you need unequal real roots. So its D should be greater than 0, not equal to. If it is equal to, why I am not putting equal to? If it is equal to, then it is equal roots. But they are saying unequal. So for unequal, it should not be there. So it is only greater than 0. Now if you see the discriminant here, b square minus 4ac, b is this one, b square minus 4ac should be greater than 0. Now because you need a value of b, you try to make it a quadratic. You have an expression of AB mix and you try to make it an expression for b only. A quadratic expression of b only. So b square plus b plus constant. X square plus x plus some constant. That's why it was written in quadratic format. So was first square, then 1, then no power of b. So it is written in this fashion. Now it should be greater than 0. Now this is an expression. Now if I want to draw this expression, if I want to quadratic expression, I can draw the graph. You can see this graph I can draw. Because that should be greater than 0 always. This should be greater than 0 for every value of b. That means you need a, and it is also a positive because it is 1, so it will be smiling parabola. So your parabola will be upside, looking upward. That is a smiling parabola, and it cannot cross x-axis because you see everywhere the value of function is positive. But if it cross, then somewhere it will be negative. So it should not be negative, it should be positive, it should be true for all values. So if it is saying that for all values of something and you got a quadratic equation expression of that variable, and if it is said for all values, then it will be either smiling parabola without crossing x-axis, or it will be a crying parabola without crossing x-axis. Smiling or crying will depend on the value of that b square, coefficient of b square. So you can see it should be something like this, it should not cross. Then what is the representation of this one in my quadratic expression? Imaginary roots. That means your d should be less than 0. So what is d here? If you see, this is my d, b square. B square means if you take 2 common, it is 4. So I have directly written b square minus 4 into a into c, this one. So this one should be negative. So if you see this one should be negative, you draw the expression, you will find this. I have told you, if you multiply minus, this sign automatically changes. If the roots of the equation, this is the square of the another one. One root is the square of the another one. So if I take alpha, then another one will be alpha square. Then you need to find something expression of PQ. Okay. So I have one alpha square. So if I add these two, this one I know. If I product these two, I know. So I need to have an expression of PQ so that I have to eliminate alpha. Then how to eliminate alpha? If you put alpha cube, you know. So better you convert it into cube. And you see also there is expression of p cube. Everywhere there is a p cube. You can get hint from option also. So obviously you need to cube this one. Take a cube of this one so that you can find p cube. So if I take cube, similar expression we have also done in one more questions before in the first lecture. You can see by cubing both sides we have also done. So if you take this one, so it becomes easy. Alpha cube is directly given q, and this is alpha cube square. So it is q square, and this is directly minus p, so you can write. So you will finally get the expression. So from the question you should get some hint, because this is given and some expression of pq, so that you have to get, so you have to eliminate alpha. And while eliminating alpha, you check the options. Every option has pq, so that means you need to cube this one. That is for sure. So you start with that one, you will get some conclusion. Again for all x real, you will find this one. I have marked this one to zoom it, so that you be clear with this one. If x is greater than 0 for all x. For all x means it is a smiling parabola again, so its shape will be again like this. So that's why I have written also. For all x means it should be upward or downward facing parabola with no real root. It should be either this or this. That depends on coefficients of x is a positive or negative. So because it is positive 1, so it will be upside, looking upward, smiling parabola. It is smiling. So again, what is the condition? That means d should be less than 0. So this is my d. You can easily now find. Once you do this one, then if you express it in quadratic, split it in two terms, you will find this one. It is a standard format. You will put a pole at -5, you will put a pole at 2, then plus minus plus. You need negative portion, so answer is this one. Very simple one, standard one. The idea is only to hit at this point. So this was your critical point. So you have to find all these things in the questions. Find the range of values of t for which this is equal to this. Now you have a trigonometry expression here, and your t is already defined. It is minus pi by 2 to pi by 2. That means this quadrant and this quadrant. Minus pi by 2 is here, pi by 2 is here. 0 degree, 90 degree, 180, 270, then again 0. Positive 90, negative 90. So your angle is defined here. This t is defined here. So because your angle is defined here, so here sine has all values. In the first instance, sine, in fact, if you put any angle in sine, you will get always output. Only tan there is a problem. If you put infinity pi by 2, then output of tan is undefined, that is infinity. But in case of sine cos, you can put any damn thing inside, you will get something output, and something within the range of -1 to 1, because sine, the output of sine is, or cos is, between -1 to 1. That means you will get real output. Once you get real output, that means this side is real. This is for sure. So once this side is real, that means this side has to be real. So once this side has to be real, that means your x has to be real. Then only this side will be real. Okay. That means your x is real. This is the one condition they have given. So from this only, using the trigonometry, basic trigonometry, because left hand is real, right hand has to be real. So now if you take product, cross product, and you make it a standard quadratic equation format, this one. Now, because your x should be real, because left hand is real, right hand real, then what is the condition I have? My d should be greater than 0. So my d, what they are asking, find the range of values of t for which this should exist. So you have to find the range of t for which this exists, means algebraic expression is equal to trigonometry, and this trigonometry is giving real output, so algebra should also give me real output. So my x should be real. So when x should be real, when d is greater than 0, if you put d, b square minus 4ac, you can put b square minus 4ac, you can take easily, I think, and you can do this product, this one, I think you can easily do these calculations. Finally you will arrive at this point. Now when you arrive at this point, this is again a quadratic of sine t. Can you find the root of this one? No, directly it cannot be found root. So what I can do, because I need to find the range of t from where t should vary, or t from where to where t can vary. So that means I have to find the range of sine t also, for which this is satisfying. So what should I do? Again from here I cannot, because here a, b, these are all known. You cannot write it is, and it is not greater than 0 for all value of 2. No, it should be 0, and now you are finding for what value of t it should be 0. Now if you try to factorize this one, you will find, I think you can see here, I am doing the factorization here, minus b plus minus b square minus 4ac by 2, so you will find these factors. So you will find these factors, sin t, one factor is this one factor is this one. Suppose this is alpha, this is beta. So now what you will write? You will write sin t minus alpha into sin t minus beta. This product, because they are roots, so you can write it, 1 minus this, 1 minus this should be greater than 0. If it is greater than 0, then what you will do? You will insert poles. Suppose this is 0, there is no pole. Suppose this is 0. So one is at 1 plus root pi by 4, one is positive, 1 plus root pi by 4. And one is negative, 1 minus root 5, because root 5 is 2 point something. So it will be obviously negative. So 1 is here, so one pole is 1 pole here, again plus minus plus, so you need greater than 0, so answer will be this and this zone. So you can see here your answer is sin t is from minus infinity to this position, and then from this position to this position. Now for sin t you have to remember this formula. For sin 18 degree is root 5 minus 1 by 4, cos 36 is root 5 plus 1 by 4. So this formula you have to think. So because it is minus infinity, so but what you are saying sin t is between minus infinity to this much and this, but sine output cannot go between minus 1 to 1. So this side you have a Lakshman Rekha, now you have a boundary, you cannot cross minus 1, this side you cannot cross plus 1, because the output of sin t, you are saying sin t is between these two. So sin t value cannot go beyond plus 1 and cannot go fall less than minus 1. So it should draw between. So it should be minus 1 to this and then this to 1. So it should be minus 1 to this and this to 1. Now minus 1 is sin minus 1 is minus pi by 2. So for minus pi by 2 you are starting from here, and this one is negative of this one 18 degree. So it is minus 18 degree. So you can come from here to here 18 degree. This is minus 18. This is minus 19. So you can move from here to here. And another one is this is your 3 pi by 18. If you do this one, because it is cos 36, which is nothing but sin 54. Sin 54 can be written as this one. So it can be from 54 degree to it will reach 90 degree. So t can vary from here and here. So here you can have t and here you can have t in these two quadrants, so that expression remains true. Trigonometric expression equal to algebraic. Trigonometry real, algebraic real. From that we started all this journey. If you like the video, then press the like button and please give your valuable comments in the comment section.